Hello, everyone, and welcome to our week session. Hope all of you are safe and healthy. Today, we have an interesting topic. We're talking about artificial intelligence and Industry 4.0. As always, we have our good friend Eric Arnum here with us. Eric, of course, manages the warranty weekly newsletter that goes out there. He's been an integral part of the warranty space for a long time now, and is at this point a full-time volunteer in New York City. So thank you, Eric, for joining us. We also have Atul Varshneya here with us. Atul is our Vice President in the artificial intelligence space here at Tavan. He has been an integral part of machine learning and the AI space in multiple industries, brings lots to the table. So today's conversation should be a pretty good and engaging one. So over to you, Eric and Atul.
Thank you, Roshan. And good afternoon, good evening to all our attendees. I'm just going to speak very briefly about some practical examples I've seen in recent weeks. Because of the pandemic in the world, the provision of customer service and on-site repairs has changed very radically. Many of the top automotive and electronics brands, appliance brands, have found ways to extend their warranties that would have otherwise expired in March, April, or May. They've extended them to later on in the year to June or July because, frankly, people can't get out of the house. They can't go to work, so they can't get things repaired. They can't get them fixed. They can't get them replaced. So, warranty work has come to a halt in a lot of cases. But in other cases, some innovative companies have found ways around this. And Atul, let's go to the first slide here. I'll give you this first example. It's a home warranty company called Total Home Protection. They're launching a new CRM platform. And this CRM platform is going to use artificial intelligence to quickly match a client who's on the phone with a problem to a technician who can come to the place of business or the house and to schedule that visit at a specific date, specific time. Then it lets the customer check on the progress of the claim, check on the work that's been done, if necessary to have a live chat with the technicians, and to see what's going on, when will they get there, what will they do. And then it keeps a digital history of the entire claim so that, at some future point, people can come back to that and look at it. You see here on the slide, I put the link at the bottom. That's a link to even more thorough description of the new technology that Total Home Protection is putting into use to really, make the on-site visit as quick as possible, and in some cases maybe even unnecessary because it's been resolved ahead of time. Let's go to the next example. This is another home warranty company, American Home Shield. They're part of the Front Door is the name of the parent company, but American Home Shield is the brand name of the home warranties. Now, this is unusual. If folks who are on the call, you might remember a couple of summers ago, we had this game that we all started playing, Pokemon Go. Anybody remember that? That was an example, an early, very primitive example of the idea of augmented reality, where you point your phone at something, and the camera on the phone shows you the photo, but it also shows you some additional. In the case of Pokemon Go, it was the little characters jumping around that you had to capture. But, all fun aside, augmented reality is now coming into the warranty business. And it's because of the pandemic. It's because, well, frankly, it's in the real estate business, it's becoming impossible to have open houses to sell a home. And for the case of American Home Shield, for their technicians to get in and repair something in the home. So what they're asking their customers to do is take us on a virtual tour. Now, if it's a piece of real estate that's being sold, point your camera, in this room, in that room, in this room, and give us a tour of the house so that we can know what we're buying. But if it's the case of a boiler or furnace or a washing machine, refrigerator that needs to be repaired, point us at the problem, show us the problem. And the great thing about it is that as they're doing that, with the augmented reality, the technician can actually make notes on the screen and save that. They can ask the customer to point the phone at, the back of the unit at the serial number, and so they get the make, model, and serial number so they know exactly what they're dealing with. And then, they'll ask questions like, so point your camera at the part that's making the funny noise, and let us see up close. They'll go like this, and point the camera at the problem. Let us see the problem. Let us see the broken part before we even come to the house. Before we even roll a truck, we know what's broken. We know what part needs to be replaced. We know what that noise is coming from. We don't need to send anybody to investigate because we've already used augmented reality to make that investigation. And of course, there's no error as to make or model number, and there's no question about the serial number being valid. They know the policy number. And then, the on-screen markups are just so incredibly useful. The screenshots where you can, do the circles and arrows on the actual screenshot and say, here's the problem, point an arrow at the problem, and take it from there. So American Home Shield, they acquired this Stream augmented reality platform a year or two ago. And now what they're doing is they're making it available to all their contractors. They're also making it available to their real estate partners. So this may become the new way of shopping for a home. And you can easily see, there's nothing restricting this technology to homes. You can buy a used car this way. You can buy a new car this way. Show us the capability. Show us the product we're buying. Now with the pandemic, the rules of retail are changing. There's a whole bunch of retailers that are reopening now, but for curbside pickup only. So the possibility is that you could go shopping inside the store with augmented reality, pick out the merchandise, see how it works, see the practical demonstration, see exactly what you're buying, see them package it and put it in the bag for you, and then bring it out to the curb, all using your cell phone, your smartphone. One more example I want to show you. It's a little bit more low tech, but let's go on to the next slide. Zoom. We've all come to love Zoom in the past 2 or 3 months. My personal record is 4 Zoom conferences in one day. I hope someday to have 5, but 4 was quite enough. But Zoom is a communications platform, but again, for the service technician who's coming to the home to repair a refrigerator or a flat screen television or a piece of exercise equipment, let's use Zoom to sort of narrow down the possibilities as to what might have broken. And so, let's use Zoom. It's a simple technology that most people seem to understand pretty well. Let's point the camera at the problem so that before we roll a truck, we know what's broken, we know what parts to put on the truck, we have a good idea of what needs to be fixed. So, these are three practical examples of, it's the technology is coming into use: augmented reality, machine learning, artificial intelligence, in drips and drabs. It's being pushed by the pandemic into mass usage. We'll see what happens in the future. But now I'd like to turn it over to Atul, who's going to talk to us about Industry 4.0.
Thank you, Eric. So so I will talk a little bit about Industry 4.0 and how artificial intelligence has a very important role to play there. So basically what I'm going to do right now is that I'm going to create a backdrop for our interactive session that comes after this. And in this backdrop, I will not get into much technical aspects. I'll try not to, and just give you my view of the lay of the land with respect to the various technologies. And we'll also go through certain illustrative examples of use cases, how artificial intelligence and its companion technology of IoT are playing in the in the space of Industry 4.0. So to start, most of you, if not all of you, are, I'm quite sure, familiar with what the concepts behind Industry 4.0 are. So I will just say so much that it represents the overall trend of manufacturing technologies towards automation and other things like cyber physical systems, utilizing IoT and artificial intelligence and cloud computing and such enabling technologies, basically to improve efficiencies and effectiveness in the manufacturing space. The interest in 4.0, in Industry 4.0, has basically been rising since 2013 onwards, although the term was coined in 2011. And the interest in 4.0, Industry 4.0, has been rising even today, and it's a fairly sharp rise currently. So while this Industry Revolution 4.0 is due to this synergistic coming together of a number of technologies and enablers, and each has an important role to play in the perfect storm that has gotten created. But if one has to look at the top two, it is fairly reasonable to argue that the top two would be connected devices technologies, which is basically IoT, and the smartness in the devices and operations, which basically comes from artificial intelligence. So what we're saying is that the sensors and intelligent devices on the manufacturing shop floors, leveraging the cloud and edge computing, constantly collect valuable data, which can then be used to drive AI and machine learning models. And these models bring the smarts to enable significant improvement in the efficiencies and effectiveness in the manufacturing process. So that's my my point about AI being one of the very important elements in the Industry 4.0 technology landscape. If you look at how the industry is looking at Industry 4.0 technologies, they're generally grouped into two categories like these, as I've shown over here. One group is the connected industry building blocks, and there is a block diagram that I've shown over there because that kind of also shows the relationship among them. And the other is the supporting technologies. As I mentioned earlier, it's difficult to do a very clear black and white kind of a separation between those two, but generally speaking, artificial intelligence and connectivity technologies like basically IoT do fall into the core building blocks of technology, along with, not to miss, security. Security is becoming extremely important because of the connectivity that brings in security as one of the very important components. And system integration, of course, we can't forget about that. So AI, IoT, security, and system integration, they become the connected industry building blocks as the core components, and then there are supporting technologies. Then I just looked up a report from from the internet from a market analyst, and you can see the composition of the overall market size and how it splits across these two categories of technologies, you can see that the connected industry building blocks do constitute much larger portion of the overall market size with respect to technologies that are in the Industry 4.0. So that kind of also gives a kind of an indirect support of the idea that IoT and AI are the key drivers for Industry 4.0. Okay, so having said all that, and at least put my point forward about these being the important technologies in the Industry 4.0 space. So what are they being used for, and what are they doing to create value? So in the next few slides, I'm going to illustrate through some examples such use cases of AI for manufacturing. A lot of them are in conjunction with IoT because that's one very important component, but a few examples actually do not require IoT as a very inherent component, although it helps. So moving along, I have about 5 more minutes to cover this. So first is predictive maintenance. This is one of the most useful use cases in my opinion, and it is all about predicting device failures and the mode of failures that is likely to happen in future. And then there are other subcategories under predictive maintenance, such as remaining useful life. This basically predicts the remaining life of a part or a subsystem before it needs to be replaced. So predicting that after how much time will you need to replace it, it's lived its life. That is the RUL. And then, even without having to predict when it's going to fail or when it will need to be replaced, just determining that the combined performance parameters that you're measuring about a system that do not appear in the normal ranges is also a very useful indication that the part is due for a scheduled maintenance. And when I say combined, this is very important because I'm not talking about individual parameters being in range, because that's very easy to determine. You don't need machine learning for that. But things like that, if the temperature is high while the RPM of that machine is high, then it's kind of normal. You expect that to happen, and that should be within parameters. But if the temperature is at that level while the machine is working at a very low load, very small load, or working at a very small RPM, then that looks out of ordinary. So those kind of, when parameters are not gelling together, when they don't make sense put together, that's where machine learning comes in, and that's what I'm talking about, being able to identify patterns and anomaly so that we can then determine which something is working properly or not. Then virtual sensors is another very important subcategory. Here, basically, we're talking about that you can predict the sensor readings even while that sensor is faulty, is malfunctioning. And that basically happens by correlating its readings with the other sensors in the subsystem. And not only that, it can actually also be used to determine if that sensor is malfunctioning, because if its readings start deviating significantly from the way it would correlate with the other readings, then you know that there's something wrong with that sensor. So those kind of things are also very useful, and they all form part of predictive maintenance. Computer vision is another very important area where AI is contributing in the area of Industry 4.0. For instance, one very clear idea is visual identification of manufacturing defects. We did a project for a company where the production line ended with a person, an expert inspector, who would visually look at the part and make sure that there are no defects. So visual inspection. Now that person would, with time, over after 4 or 5 hours, the fatigue would set in, and his accuracies or her accuracies would start dropping. Similarly, multiple different experts on different lines would have different levels of expertise, and they would, their performance would be bad. So computer vision was used to automate that functionality, and it gave much better performance than the individuals, and it was consistent across, and it didn't obviously deteriorate with how long you have been in the shift. The other areas where computer vision is coming in handy is to aid robotic machines in their tasks, such as label placement, item sorting, those kind of things. Another very important area is in the area of shop floor safety and compliance. And here, basically, you're looking at the images of the shop floor and making sure that things are per the safety procedures or with respect to, and they're complying with that. And these can be done in two different ways. One is just by taking individual images and you look at that scene and work out if everything is fine. The other is that you actually look at sequence. So look at video. So how are things happening? Is the person using the tool in the right way and not causing injury to his wrist or those kind of things? So all those are part of computer vision, which are coming in very useful from the point of view of automating, and they contribute to Industry 4.0. I don't have to talk much about robotics, but just to mention that industrial robots have been in use for, I believe, few decades now. But they were robots which were programmed explicitly. But now, with newer advances in techniques like reinforcement learning, imitation learning, those kind of machine learning techniques, which are fairly advanced, cutting edge, you can actually train the robot to do its task rather than having to program it. And those robots can be commissioned in a much shorter time and can perform their tasks with much more accuracy. And cobots the collaborative robots is one very specific example of those kind of things. Finally, I just want to talk about this category. These are not very exciting from the point of view that they don't look very flashy or very jazzy, but they are extremely useful set of AI applications in the area of Industry 4.0. Let's talk about inventory management, supply chain management. So these are modeled by AI methods, and the kind of methods that are used are very simple, starting from very simple ones like time series predictions, all the way up to very sophisticated techniques as reinforcement learning. And I just make a sidebar comment over here about reinforcement learning. Reinforcement learning is actually a very advanced set of techniques in machine learning, which is not showing up so useful in many other areas because of certain limitations in that technology today. But it is it's a kind of a perfect match for manufacturing because the way it works. And I won't get into the details, but reinforcement learning is a very good match for manufacturing. That's why it, in my talk, I have talked about reinforcement learning already 3 times, I guess. So when you talk about inventory management, supply chain management, from very simple and traditional methods like time series analysis to very sophisticated techniques like reinforcement learning, they all are very useful, and they are being used. Then the category of anticipating the market. When we talk about these, we are talking about things like demand estimation. In this, AI models are used. The AI models, they use consumer data, other influencing factors, and basically what they help with is adapting to the changing market. And here also there's a spectrum of AI techniques that are being utilized, from very simple techniques like the traditionally, as people used to do, that they just look at seasonal, that around Christmas time the demand for consumer products is going to be very high, and basically look at such kind of seasonal patterns. But more modern techniques basically look at other things like financial and sales reports, marketing polls, macroeconomic factors, social media signals, even weather kind of things. So all these are taken into account to make prediction without even having to deal with the seasonal patterns. You can make very good predictions, and that's why it comes in very useful. And even things like social listening, which can be feedback, which machine learning algorithms can analyze and then provide feedback, which can lead to better product design. And finally, I want to talk about production optimization. Here, the idea is to have sensors in the process of in the manufacturing plants, thus measure the various process parameters, and then looking at the product, the produced product, we use machine learning techniques to optimize those process parameters for outcomes such as either saving energy, reducing waste, while maintaining the production quality. So production quality, there can be a lot of wastage because things are being done in some inefficient fashions, or there could be wastage. All those things could be optimized by following the recommendations coming out of the machine learning analysis of all this information. So these were the kind of things I just wanted to kind of bring out, and I think, and I wanted to, the takeaway I wanted to have from what I'm saying is AI and IoT are fairly central to the kind of to the technologies that are driving the revolution that's called Industry 4.0. Now I'll move on to the next section, and Eric, over to you. I think you would like to have some interaction, some questions.
Thank you, Atul. Thank you very much. I learned a new word from you, robot. I had not heard that before, collaborative robot. So I want to give you a new word. I just learned this morning, SODAR, S-O-D-A-R. Something Google has come out with for your phone. It's augmented reality for your phone. You can actually use the SODAR to keep people 2 meters away from you by putting an augmented reality circle on the phone. It says, you're too close, you're too close. But anyway, I wanted to ask you, you mentioned predictive maintenance. And I wanted to ask you if you could talk about maybe some of the practical benefits of artificial intelligence and machine learning in terms of predictive maintenance.
Right. Okay, so let's elaborate on that a little bit. As I said earlier, it is among the most useful, again, my opinion, and it kind of borne out by the literature that you see in manufacturing industry. So what is predictive maintenance? It's basically a method of, I think, am I on the right slide? Okay. Right. So predictive maintenance is basically a method of preventing failures of equipment, and basically it becomes more useful or has a higher impact if that equipment is expensive, like field equipments, earth moving equipments, harvesting equipments, what have you. And obviously, while I'm talking about all these, my focus actually is on the manufacturing equipment, so the machines that are used on the shop floor. And how does it do it? Is basically by analyzing data to identify potential breakdown ahead of time. And what does that do? It helps ensure appropriate measures can be taken to avoid extended periods of production downtime. So if you know that something is likely to fail in the next 3 days or next 5 days, you might schedule a repair during the scheduled downtime in the factory floor and avoid that unplanned outage later on. So just to contrast it with the more traditional way of doing preventive maintenance, where people basically talk about having scheduled maintenance. My car, for instance, goes for regular service every 10,000 miles. So that kind of scheduled maintenance. So the studies have actually shown that about half of the money spent on preventive maintenance is a waste. And why is it? Because you obviously don't want to under maintain, because you don't want to get into a situation where the thing just breaks down on you. So from that point of view, you want to make sure that you're not under maintaining, and you're also not over maintaining in the sense that you're not spending too much of money just doing all those, because that means you're wasting man hours and consuming unnecessary parts. So predictive maintenance is about taking IoT data and other data from the equipment and coming up with and using artificial intelligence to come up with a prediction of how it can fail and with what failure modes will it fail, and what is the time window in which it's likely to fail. So such kind of data like IoT, like the equipment details, its usage history, its maintenance details, these are the kind of data that the machine learning algorithms use. And they use technology, the algorithms such as deep learning algorithms, more sequential modeling algorithms of deep learning like recurrent neural networks and LSTMs and GRUs. These are the kind of deep learning techniques that are used. And also, for anomaly detection, there are techniques like autoencoders that are used to come up with such kind of predictions which help in making sure that you don't get surprised by unscheduled downtime of equipment.
So I think that's.
Do we have time for one more? Roshan, can I ask you a question?
You can, but we probably have to do it outside of the webinar. So,
Okay.
in the interest of time, and that's been the toughest thing I think Atul to do, to pack everything he knows in 15 minutes. So thank you, Atul, and as always, thank you, Eric. But we would love to hear more from all of you. Please reach out to us, and you have our contact information there. hello@tavant.com, or reach out to Eric, and we would love to have more conversations. I think everything about what we discussed today is about being, collaborative in understanding the true business problem to finally come up with a solution that is practical and not just theoretical in nature. I think that is a problem the industry continues to try to solve, and it continues to get better as more data comes in. So, but I'm sure we'll have plenty of opportunities to get into very specifics in and around this. So thank you again for your time. Have a wonderful weekend, and we'll see you next week.